go for derivative, you get the gradient of the tangent. This is actually dy by dx. And normal, the relation between them is m1. This is m1. m1 into m2 equals -1. And then we go through the coordinate geometry. Y equals mx plus c.
Wait, so we get the tangent, like the gradient of the tangent, but then like m1 comes into us perpendicular.
Yes.
So is it the perpendicular tangent or is it just normal tangent?
This one is the normal tangent that just touches the graph at any point, and we'll get the gradient by substituting that value of x. So when we have this, and if the examiner is asking about the normal or the equation of perpendicular bisector, then we use the second thing and find m2, then go for y equals mx plus c.
Okay.
Worked example, or I think we should just go to the exercise. Find the equation of the tangent to the curve at the given value of x. So for example, x is 12.5. Question number 1, A part. The equation is y is equals to x raised to power 4 minus 3, and we need to find the equation when x is equals to 1 at x is equals to 1. So whatever this graph may look like, but the gradient at the point x is equal to 1 is 4x cube. So when x is 1, the gradient is 4. So we know the gradient, we know the value of x, and need to know the value of y as well. Equation, value of x. So now we know the point, that is 1 comma minus 2. We know the gradient, which is 4. So equation could be solved y equals mx plus c, or y is equals to, or we may use y minus y1 equals m into x minus x1. Both will end up same. So y is -2, gradient is 4, x is 1. 4 goes on the other side, we get c as -6, and the equation is y is equals to 4x minus 6. If I use the other side, this is how we do. We substitute it in one go. Y was -2, and then gradient was 4x minus 1. So that's y plus 2 is equals to 4x minus 4. 2 goes on the other side, 4x minus 4 minus 2, and y is equal to 4x minus 6. So this is the equation of tangent to the given curve at x is equals to 1. Now all that matters is concept is same everywhere. All that matters is we should know how to differentiate. Question number 1, E part. Question says y is equals to x minus 3 into 2x minus 1 whole squared at x is equals to 2. See, the storyline is same. We need to find the equation of tangent to this curve at x2. So dy by dx is first function into differentiation of second plus second function into differentiation of first. So when x is 2, 2 minus 3, 2 into 2 to the 4 minus 1 is -3. 2 to the 4 minus 1, 3 squared. That's -1. 2 to the 4, 4 is -12. 3 times 9. That's 12 plus 9. And at x2, gradient is 21. Now we already have value of x. We have value of gradient. I need the value of y. So y is equals to x minus 3 into 2x minus 1 whole squared. And when x is 2, 2 into 2 minus 1 squared. 2 times is 4. 4 minus 1 is 3. 3 square is 9. 9 into minus 1 is minus 9. So the summary is that the gradient is 21 and point is x2 y minus 9. And there we go with the equation of tangent. Y minus y1 equals m into x minus x1. Y minus y, gradient is 21, x minus 2, y plus 9 equals 21x minus 42, y is equal to 21x minus 42 minus 9, y is equal to 21x, and 42 and 9 is 51. This is the equation of tangent to the given curve at the given point. Similarly, the nature won't change. There's one extra step when we go for normal. It says find the equation of the normal to the curve at the given value of x. So let's
So
try.
normal to the curve would be the perpendicular bisector.
Yes, perpendicular. Perpendicular at that point. We will call it bisector if we know that we are dealing with the midpoint of any two.
Okay.
Question 2a. Y is equals to x square plus 5x at x is equals to 1. So at all times, we should be confident that we know how to differentiate it. We should just know the storyline. So we're going to find, let's say this is the curve and it is tangent at x is equals to 1. So the perpendicular at this point is going to be this. So I need to find the equation of the perpendicular. So first thing first, dy by dx is 2x plus 5. And when x is 1, the gradient is 7. Gradient is 7. So what would be the gradient of m2? That is
Negative
m1
one.
into m2
Negative one.
equals minus 1. Yes. 7 into m2 equals minus 1. m2 is equal to minus 1 by 7. Now we know the gradient. And if we know what we need, we can, I'm looking for y now. We could find this earlier as well, no matter what the order is, but we are collecting the data. Y is 6. Now I have all the data. X is 1, y is 6, and the gradient of the normal is minus 1 by 7. What are we left with is equation. Y minus y1 equals m into x minus x1. So y minus 6 is equals to gradient into x minus x1. So 7y and 7 6 times is 42 minus x plus 1. 7y equals minus 6 plus 43. This is the equation. This is 12.5 question 2a. 12.5 2a. Minus 1 by 3. Gradient is 1 by 3. What did I do? X square plus 5x. Equation was x square plus 5x. So derivative is 2x plus 5. X minus 1. Why did I substitute 1? X was minus 1. I'm doing that again quickly. Y is equals to x square plus 5x. X is equals to minus 1. So y is equal to minus 1 squared plus 5 into minus 1 is 1 minus 5. It's minus 4. So the point is minus 1 comma minus 4. On the other side, y is equals to x square plus 5x. The derivative would be dy by dx is equals to 2x plus 5. And the gradient when x is minus 1 is minus 2 plus 5 is equal to 3. So m2 would be negative 1 by 3. y minus y1 is equals to m into x minus x1, where y is minus 4, gradient is minus 1 by 3, x is minus 1. Y plus 4 is equal to minus 1 by 3, x plus 1. 3y plus 12 equal to minus x minus 1. 3y is equals to minus x minus 13. Y is equal to minus 1 by 3x minus 13 by 3. Now let's see. This was 12.5a minus 4 is a 12, 13. Now it's correct. Try question number 3. Is the concept clear?
Yeah.
Try number 3.
Y equals 6.5x plus 1.5.
Question number 3. Y is equals to hmm, find the equation of tangent and normal. What is the equation of tangent?
Oh, and normal. Equation of tangent, I was getting y equals 6.5 plus 1.5. 6.5x plus 1.5.
And this is different. Let's do it together. So first of all, the curve is y is equals to 5x minus 3 by x. At x is equals to 1. Y is equals to 5 into 1 minus 3 by 1 is 5 minus 3, that's 2. Now we know the coordinates and we are interested in gradients now. Y is equal to 5x minus 3x raised to power minus 1. So dy by dx is 5 minus minus plus 3x minus 2. That's 5 plus 3 over x square. At x1, 5 plus 3 over 1 square is 8. So m1, that is for tangent, is 8 and m2 is negative reciprocal, that is for the normal. So we have the points and we have the gradients. Points are 1 comma 2. 1 comma 2 for gradient 8, this is the equation of tangent. 1 comma 2 and gradient negative 1 by 8, this is for the normal. So y minus y1 equals m into x minus x1, where y is 2, gradient is 8, x is 1. Y minus 2 equals 8x minus 8, y is equals to 8x minus 6. Equation of tangent. And y minus y1 equals m into x minus x1. Y is 2, gradient is negative 1 by 8, and x is 1. 8y minus 16 equals minus x plus 1. 8y equals minus x plus 17. Y is equal to minus 1 by 8x plus 17 by 8. And if we wish to change it into mixed number, 8 2 times is 16, 117 by 8. Where are you getting different numbers? Is the derivative same?
Well, I think instead of, because when I was rereading it, I was getting the 8 and it was plus, but then when I rewrote it, with the y equals to 5x, I wrote 5x plus 3 over x, not minus.
Okay. So 3 is y equals 8x minus 6 and y equals minus 1 over 8x plus 17 by 8. Similarly, question number 4. Now, our prime focus is coordinates and gradient for any equation, either it is tangent or normal. So it says the normal to the curve this at point this intersects the y-axis at point P, and we need the coordinates of our point P. So first of all, our approach is to find the equation of normal. Y is equals to x cube minus 2x plus 1. So dy by dx is 3x square minus 2. So at x2, 3 into 2 square minus 2, 12 minus 2, this is 10. Now the gradient is 10. And at that point, m1 into m2 equals minus 1 because we are interested in normal. Gradient of normal is minus 1 by 10 and it passes through 2 comma 5. We don't have to find that. And the given point is 2 comma 5. So for the equation of normal, y minus y1 equals m into x minus x1. Y is 5. Gradient is minus 1 over 10. X minus 2. So that's 10y minus 50 minus x plus 2. 10y is equals to minus 50 plus minus x plus 52. This is the equation of the normal. And then it says the normal intersects the y-axis. So on y-axis, we know wherever it would intersect, we know x will be 0 and y is unknown. So when x is 0, 10y is equals to 0 plus 52, y is equals to 5.2. So the coordinates of P are x0, y 5.2. Option number 4, 0 and 5.2. Is that clear?
Yes.
Okay. Now that's going to be a bit long question. Question number 6. First, just let me know what the story is and then try that. Read the question.
Okay. So we have to find a tangent to the curve. The tangent to the curve's equation is this. And at the points 1, 0, 3, negative 2, they meet at the points Q. So we find that we find the coordinates of Q. So that would mean we would find the points that they intersect on the tangent.
Yes. We're going to find two equations of tangents, one at 1, 0, the other at 3 minus 2. Two equations of tangents, and then we are
Oh,
going
okay.
to solve
So I'm
those two tangents simultaneously because those tangents are meeting at point Q.
okay.
If you want to picture it, this will somehow look like this, that we have these two tangents and they're intersecting at Q.
Okay. Should I work on it?
If you're very confident, we can change the question to try new type. If you have slight discomfort, we should do it.
Okay, I'll try to do it just in case.
And meanwhile, I was just looking at number of chapters. This is differentiation 1. If we would continue without breaking the continuity, we should step on to chapter number 14, that is differentiation 2, then 15 integration, then kinematics 16, and then we'll be left with only two vectors and permutation combination.
And then we can start doing yearlies.
Yep.
2 and negative 3.
Question number 6. Correct. Very good. Okay. Small increments and approximation. Again, this is linked with differentiation. And as the diagram is showing, slight change in y would give slight change in x. The diagram shows the tangent to the curve y is equals to f of x at point x comma y. The gradient of the tangent is dy by dx. Point q is x plus, we read it as either delta x or small change in x. So x plus delta x and y plus delta y means small change in x and small change in y. In this case, if I'm talking about small change in x, that is moving right side. Small change in y, that is moving upwards,
But why is it small change in x and small change in y?
because we're considering so. See this point and let's say this point. They're two different places and far away. And if I talk about this point, then this will be a small change between these two. Small change in x and small change in y. For example, x was 2 and then the new x is 2.01. Slight change, small change. So what effect does that have on the gradient or curve or values?
But how are we changing it if it's just one straight line?
Given that it is changing by 0.01 or something.
But
And
how is it changing?
as you just did, you found the gradient at value x something and then a new value. So that's how we'll consider that if it changes, let's say from x is equal to 2 to x is equals to 2.1. That is a small change. What effect will that have on the gradient?
Basically, no effect, right?
Please say that again.
Basically, no effect, right?
No what?
Basically, no effect, right?
No, there will be an effect. That would definitely be small as well.
Okay.
Okay, the gradient of the chord PQ is okay. We changed it. This was the first point. This is the changed point. So if we find gradient of this point, that is definitely change in y over change in x, and that is approximately equal to the gradient because it is a small change. Now the question says variable x and y are connected by the equation given y equals x cube plus x square. Find the approximate increase in y as x increases from 2 to 2.05. So what is the focus? What is the formula? dy by dx is equals to change in y over change in x. So as x increases from 2 to 2.5, so first of all dy by dx done. And when x is equal to 2, we know the gradient because we are going to substitute the gradient here. And see, x changes from 2 to 2.05. So gradient is 16 and change in x is 0.05. If it would have been decreasing, we'll substitute negative value. So I can find the change in y. We multiply 16 into 0.05 is 0.8. The change in y will be 0.8. Whatever value y was, it would increase by zero point 0.8.
But I'm still not clear about how it changes, though. Like the value changes.
Because we are changing the value of x, we are changing the point. For example, this was the curve, and at x2, we knew the gradient was something, and the gradient was 16. dy by dx was 16. And now we changed the value from 2 to 2.05. So 2.05, we are now here. If we are changing,
Oh, the tangent.
yes,
Okay.
it is slightly changing. So
Okay.
slight change, this is equal. Because of slight change, the gradient slightly changes. So we found the new y. The old y was, he didn't ask for it, but just to clarify, 2 cube plus 2 square. 2 cube is 8 and 4, 12. So new y is zero point 0.8 more than that. So if it was 12, new y would be 12.8. Small change in x results in small change in y. They result in small change in gradient. That's it.
Okay.
The volume V of the sphere is given by V equals 4 by 3 pi r cube. Find in terms of P the approximate change in V as R increases from 10 to 10 plus P. Now see, R is clearly 10 and 10 plus P is new R. I can say change in R is P. And the demand was find in terms of P the approximate change in V. So dV over dr is change in V over change in R. Change in R is already given. Change in V is unknown. And dV over dr, how do we do that? We differentiate it and then substitute the value of R. So we have three things. One, we have these two things, and we can find the third one.
So we differentiate the
Volume.
formula,
Yeah.
and then we get 4 pi r, and then afterwards we substitute the r into it. So r equals to 10. Then we have 400 pi, and then afterwards we substitute the p into it and the 400 pi. Oh, and then we get a value like undetermined equation, right?
Yes. In terms of P. For
Okay.
this. Okay. See question number 1. It says variable x and y are connected by equation y is equal to 2x cube minus 3x. Find the approximate change in y. So change in y is unknown. At all times, I have this in mind. dy by dx is equals to change in y over change in x. So this is unknown. Whereas I should have the other elements. So dy by dx is 6x minus 3. At what point? At 2. So gradient is 9. Now we substitute. dy by dx is change in y over change in x. dy by dx is already 9. Change in y is unknown. And what is the change in x? From 2 to 2.01, the change is 0.01. The change in y is 0.09. Question complete. 12.6, question 1. Why is it 0.21? Oh, my bad. Differentiation 3, 2 times 6. This is squared. 2 to the 4, 6 is 24. 24 minus 3 is 21. So gradient is not 9. That's 21. 0.21 and 0.21. Question number 2. Variable x and y are connected by the equation this y is equals to 5x square minus 8 over x cube. Y is equals to 5x square minus 8x minus 3, where dy by dx will be 5 2 times 10x minus minus plus 8 is a 24x minus 4, 10x plus 24 over x4. So gradient at what point? Variable x and y are connected by this equation. Find the approximate change when y in y as x increases from 1.1.01. So x is 1. 10 into 1 plus 24 over 1 raised to power 4. 10 plus 24, this is 34. So dy by dx is equals to change in y over change in x. Small change in y over small change in x. So dy by dx is already 34. And we need to find the approximate change in y, that's unknown, and change in x is 0.02. So change in y is 34 into 0.02, that is 0.68. Question number 2, 0.68. Okay. Try number 4.
So equals to 6p?
Number 4, 2p.
2p.
Variable x and y are connected by this equation. Y is equals to x by 3 minus 2 power 6. dy by dx is 6 comes down, x by 3 minus 2 power 1 less, and then multiplied with whatever is inside. Differentiation of that is 1 by 3. 3
We
1.
have to also differentiate it? Oh, we multiply with the differentiated value on the inside?
Yes.
Oh, okay.
That's how you're getting the difference 6 and 2. So from 9 to 9 plus p, 9 by 3 minus 2 raised to power 5. 9
That's just 2.
by 3 is 3 minus 2 is 1. That's just 2. So yeah, dy by dx is change in y over change in x. Gradient is already 2. Change in y is unknown. Change in x is p,
So 2p.
2p. See, the whole point lies in how to differentiate any given thing. How to differentiate.
Okay.
I'm going for question number 6. A curve has equation y is equals to x minus 2 into square root 2x plus 1. Find in terms of p the approximate change when y as x increases from 4 to 4 plus p. So dy by dx is first function into differentiation of second plus second function,
Why did we differentiate the square root like that?
because I've done my practice. What others would do is this.
Oh, yeah. So then it would just be 1 over.
Okay. So this is x minus 2 over square root 2x plus 1 plus square root 2x plus 1. And it was when x is 4. So 4 minus 2 is 2. 4 2 is 8, 1 9 by square root is 3 and 3 11 by 3. And now the change. dy by dx is equals to change in y over change in x. 11 by 3 and change in y is unknown from when it changes from 4 to 4 plus p. The change in y is 11p by 3. Question 6. 11p by 3. Try number 8.
I'm getting for A part I'm getting 180 over x squared. Then for B part I'm getting, yeah, and then for B part I'm getting 4x squared plus 1080 over x. And then for C part I'm getting negative 254p.
That's right. And the word decreases because you're getting it in negative.
Yeah.
Okay. The rate of change. That's similar somehow to this. For example, we have one equation y is equals to 2x cubed plus 5x. So what we'll be looking at is dy by dx and change in y, rate of change of y and rate of change of x. So we're looking at these three things. What we did earlier was small change. Now this is the rate of change in y and rate of change of x. Definitely if x is changing, we are getting changing y. So if the change rate of change of x is more, rate of change of y is expected to be more. How do we write them? We also call it chain rule. Dy by dx is equal to, I'm writing dy by dt, but I have to take the reciprocal of this dt over dx in order to make left hand side equal to right hand side. We just have to be a little careful while substituting that we have to use the reciprocal of dx over dt. Some students do their practice and they may wish to write it directly. When you have to find dy by dt, they may make it the subject of the formula. So dy by dx into dx over dt would work. See again, left hand side is equal to right hand side. So whatever we are writing, before substituting, we'll look closely what we've written and then substitute the value. For example, variables v and t are connected with this equation, and rate of change of t, this is straight away t. Volume is related to time, so we don't have to go through the chain rule. That is directly the answer, dv over dt. And at any time, at time is equal to 4, we have the rate of change of volume. Now if that's 32, that means the volume is increasing at this rate, 32, whatever the unit is, for example meters, meter cube, so 32 meter cube per second or anything else. So these are the connected rate of change. If y is having a rate, x is having a rate, so overall we'll write it like this. Worked example, variable x and y are connected by the equation y is equals to this, given that x increases at a rate of 0.1. Say y is equals to x cube minus 5x square plus 15. So dy by dx is 3x square minus 10x. And x increases at a rate of 0.1 means dx over dt is given. Positive means increasing units per second. Find the rate of change of y. So I'm done with dy by dx and I know the value of x when it is 4. So 3 into 4 square minus 10 into 4. 4 times is 16. 16 into 3 is 48. 48 minus 40 is 8. Now we write our equation. Dy by dx is equals to dy by dt into dt over dx. Left hand side equals right hand side. So dy by dx is 8. Substitute.
Is
And
there a way to relate like this dy or dx equals dy or dt times dt or dx to the other one that we learned? So the one where it was like the one from the other chapter?
same
Or
chapter.
like subunit, like subtopic?
Subunit, subtopic, yes. So dy by dt is unknown. The rate of change
No,
of,
is there a way to relate them? Because this is about rate.
yes. There is, first of all, this is the derivative. Derivative gives you the gradient. For example, I have volume on y-axis and I have radius on x-axis. So this would give me that the rate that is change in v over change in r, that how the radius changes affects the change in volume. So that is gradient. And then we studied small change. We were at this point. If I increase the radius small, a small difference, what difference will it make in the volume? Then we studied small change in volume or small change in radius, and then leading towards if they are connected differently, like a radius is changing with respect to time, what will this have the effect on volume changing with respect to time? For example, we have this cone and I'm filling this up with the tap. Water keeps filling. What do you see? Is the radius increasing?
Yes, it is.
So that is the rate of change of radius, definitely with respect to the shape. That is why we'll have an equation of volume as well. On the other hand, what happens to the volume? Is it changing dV over dt?
It is also changing.
Will it be dependent on radius?
It's not dependent because it's dependent on the time.
Okay, it is not dependent. May I say it is related, or they could be related through another variable, that is rate of change of volume, um, rate of change of volume and rate of change of radius could be related through this chain rule to the gradient dv over dr. Because left hand side equals right hand side. If I would simplify, I'll get them same.
Okay.
So leading from dv over dr to small change in over v or small change in r to a rate of change of volume and rate of change of radius.
Okay.
So rate of change of x in this case is already given in question, that is 0.1, and when I substitute I'm writing 1 over 0.1 because that was reciprocal. So this point 0.1 goes on the other side and multiplies, so I'm getting rate of change of y as 0.8.
But wasn't x value the 4? We can't put that back into the
That
dx.
is 4. We substituted that in dy by dx to get the
Yeah.
gradient.
But then afterwards, we just have to put it as 1 over 0.1?
1 over 0.1 is because now I'm not substituting x, I'm substituting dx by dt. X was substituted in x.
Okay.
dx over dt is not x.
Okay. But then where did we get the value just 1?
That will be given in question. No, yeah, this numerator.
Yeah.
No, no, no. See, dx over dt was given 0.1. So what will be dt over dx? That's a reciprocal.
Oh, 1 over 0.1. Okay. And then what value did we get? So then it gives us 0.8?
Yes.
Okay.
Substitution. Okay, the length of the water container in the shape of triangular prism of length 120 meters. The vertical cross section is an equilateral triangle. Water is poured into the container at a rate of 24 centimeter cube per second. See, this is volume per unit time. So I know this is dV over dt 24 given centimeter cube per second. Then it says show that the volume of the water in the container is given by this. So volume of container must be cross sectional area into height, where height is 120. So it is already given that this is equilateral triangle. So you assume an equilateral triangle and give the given the height is h. So cross sectional area must be 1 by 2 into base into height. So we're using the trigonometry 60h. So this is length of one side is using sine. Let me do it my way. So 1 by 2 into base into height, equilateral triangle, yes. For example, we're finding this. So may I use sine 60 is equals to perpendicular over hypotenuse. The perpendicular is this, and let me call hypotenuse x for now. So x is equals to h over sine 60. That's how he's finding sine of one length, h over sine 60. And because it is equilateral, so you can write h over sine 60 on all sides. H over sine 60. So area of triangle is 1 by 2 into base into height. 1 by 2 is there. Base is sine 60. When we simplify sine 60, we get the value. So just quickly check what do we get. Sine 60 is square root 3 by 2. So 1 divided by answer, I'm getting 2 square root 3 by 3. So 1 by 2 into base into height is the cross-sectional area. Cross-sectional area into length 120. And this could be simplified to show that the volume is 40 square root 3 h square. Once done, find the rate of change of height. We derivate it to get dv over dh. See, volume is there. You derivate it, you get this. At what point? When h is 12. Substitute h. Now dv over dh is there. See, dv over dh is equal to dv over dt multiplied with dt over dh. Is left hand side equal to right hand side in this chain rule?
Yeah, left hand is and
Now
right hand.
dh is right in front of us. When we substitute h as 12, you get 960 square root 3. Then rate of change of volume was already given, that is 24. So in order to find that, now you just have to make it subject. So this goes on the other side as dh over dt is equals to 24 over 960 square root 3. And then we use calculator and get the value. Rate of change of height is square root 3 by 120 centimeters per second. Let's try question 1. Exercise 12.7, question number 1. Variable x and y are connected by the coefficient this. Y is equals to x square minus 5x. Given that x increases at a rate, so dx over dt is given. Find the rate of change of y. Okay. So first thing, I need the derivative. dy by dx is equals to 2x minus 5. At what point? When x is 4. So 2 into 4 minus 5, 2 4 times is 8. 8 minus 5 is 3. So I'm writing some values. dy by dx. dy by dx is equals to dy by dt into dt or dx. I'm going to make the substitution slowly. dy by dx is clearly 3. On the other side, given that x increases at a rate of 0.5, see dx over dt is given 0.05. And here I've written dt over dx. So I can reciprocate it and find dy by dt. This just goes on the other side. 3 into 0.05 is rate of change of y, and dy by dt is equals to 0.15, and that was units per second. So units per second. Try question number 2.
I'm getting 0.125 units per second.
Question due to 0.125 units per second. That's correct. Yes. It's a long chapter. Okay. We'll start this concept in our next class and probably complete the chapter in the next one.
Okay.
Anything you would like to ask?